Hello and welcome to another digital logic design class. Today's class would be a review for our upcoming exam, the first exam. I'll post the instructions for the online students on the date and the other instructions for the upcoming exam for the first midterm exam of digital logic design. Today I would solve some practice problems that would be on the exam. By the way, the exam would be up to the Boolean algebra and the manipulation of Boolean algebra, how to simplify that. And we would, it will cover the number systems, it will cover complements, it will cover logic gates, and Boolean algebra, the table that we had for the theories and for the postulates. Okay, so without further ado, let's start with the review class. If you have any questions before the class starts, I'm open to answering any. Do you have any questions from the previous class? No? Okay. Yes.
But all topics will have on this.
So anything that we covered up to the last day of the class, the previous class.
Yes.
Up to the day before yesterday, yes, on Tuesday, which is 23rd of December. So anything that we covered before 23rd of December, I'm sorry, September. Why do I keep saying? So up to 23rd of September, anything is covered. And you would see from the questions that I solved today on which topics are covered. One thing that to keep in mind, please practice on the problems that I solved today. The problems that you're going to see on your exam are going to be very similar to these problems. The only difference would be I would slightly change the numbers. Obviously, I don't want the exact numbers to be on the exam, but it's going to be very similar to those that you see today on the review session. So the first problem, we want to convert 321.2 in a base of 4 into base of 7. Again, I'll give you a few minutes to solve this, and the first student to solve it gets extra points and bonus points. For the online students, you can directly skip the video to the answers. You can think on it, try to solve it on your own. This time is good for you to go ahead and solve it, and then you can skip to the solutions. Did you solve it? Can I solve it? It's okay. Okay. So we can't directly convert the base of 4 to base of 7. What we need to do is first convert 4 to the base of 10 or decimal, and then convert it to the base of 7. To do that, we would write it like this. It's going to 3 times 4 in the power of 2 plus 2 times 4 in the power of 1 plus 1 times 4 in the power of 0. This is the decimal part. So this is going to be equal to 3 times 16, which is 48, plus 2 times 4, which is 8, plus 1 times 1, which is 1. And the decimal part, it's 0.2. Forgot. That one is going to be equal to 0.2 times plus 0.2 times 4 in the power of negative 1, which is going to be, or 2 times 4 in the power of negative 1, which is going to be 0.5. So the result would be 57.5. Now we have to convert 57.5 to the base of 7. To do that, we would divide 57 by 7. It's going to be 8, and the remainder would be equal to 1. Then we divide 8 by 7. It's going to be 1, and the remainder would be 1. And then we divide 1 by 7. It's going to be 0. The remainder is going to be still 1. So 57 in the base of 10 would be 111 in the base of 7. Now, we convert the decimal fraction part, which is 0.5. We have to multiply it by 7. It's going to be 3.5. The remainder is going to be 0.7. We keep the 3, and we multiply the 0.5 by 7 again. I'm sorry, 0.5. Again, we're going to have 3.5. Again, 0.5 is not, we don't have 0 in the fraction part, so we keep multiplying it, and we get the same thing. So 0.5 in the base of 10 is going to be 0.3 on repeat in the base of 7. So the final answer would be 111.333, or we can write it like this, 111.3 on repeat.
2 times 4 to the negative 1, 0.05.
Yes, this would be 2 times 1 over 4, which is 0.5. Is it clear? So again, we cannot directly convert base of 4 to base of 7. We have to first convert it to the base of 10 to decimal, and then from decimal to the base of 7. Can I go to the next question? Yes? Okay. Now, the next question, we have 624. Octal in the base of 8, and we want to convert it to a decimal number.
Does anyone have the answer?
Perfect, yes. The answer is 404 decimal. So it's going to be 6 times 8 in the power of 2 plus 2 times 8 in the power of 1 plus 4 times 8 in the power of 0. 6 times 64 is going to be 384. 2 times 8 is going to be 16. And 4 times 1 is going to be equal to 4. So we're going to have 4 times 1 is going to be 4. 4, 16, 384. So the final answer would be 404. I want to move fast so we could solve more problems. Okay, a little. So the next question, what is the binary multiplication of 10110 multiplied by 01111? Okay, what is the answer? So 1 times this is going to be 0. Do it this way. 0, 1, 1, 0, 1. We will shift it 1. So 0, 1, 1, 0, 1. We're going to shift it another. So we're going to have 0, 1, 1, 0, 1. And we're going to shift it for the 4th time because we have 4 ones. So 0, 0, 1, 1, 0, 1. And the last one that we shift, it's going to be 0, 0, 0, 0, 0. Is it correct? Yes. Okay. Now let's add them together. This 0 comes down. It's going to be 0. This becomes 1. 1 plus 1 gives us 0. 1. 1 plus 1 plus 1 gives us 1. 1. 1 plus 1 plus 1 gives us 1. 0. 1, 1. Sorry, 1, 0, 0, 1. So 1, 0 plus 1 plus 1 gives us 1, 1. 1, 0, 1, 0, 1, 0. So the final answer is 1, 0, 1, 0, 0, 1, 0, 1, 0. This is one way to solve it. Another way to solve this, if you don't like this way, you would simply convert these two to the decimal. If I convert them to decimal, I think this would be 22. This would be 15, yes. And then you multiply 22 by 15, you get 330. And then you can convert 330 to back to decimal, put it back to binary. And you're going to have 1 0 1 0 0 1 0 1 0. Okay, this is a relatively easy one. The next one, we want to find the 2's complement of A. Okay, did you write the final answer down here? So 1 0 1 0 0 1 0 1 0. Please double check because I do it in my, on top of my head. I'm not out of memory. Just please double check to see if it's correct. Now, the next one, we want to find the 2's complement of A equal to 1 0 1 1 0 0 1. What is the answer? So the easiest way is first to find the 1's complement. Simply, we would replace the 0's with 1's and the 1's with 0's. So this would be its 1's complement. And then we would add 1 to it. So it's going to be 0 1 0 0 1 1 1. So the answer would be 0 1 0 0 1 1 1. Other way to solve it that you learn is the first one from the right, we keep it, and then we change all the zeros to ones and ones to zero. It's going to be 1 1. I'm sorry, 0 1 0 0 1 1 1. If we want to write it from. Now, part 3C, we want to find the result of the subtraction A minus B using the radix complement of B. And B is equal to 1 0 0 1 1 1 1. And for your own practice, find also B minus A. It's going to help you. At home, you can do that as well. Find B minus A as well. Did anyone solve it? Okay, the first thing we need to do, do you need more time? Yes. Who solved it? Okay, I'll give you a few minutes. 4 or 5 minutes. Another 4 minutes.
Radix means the two's complement.
Yes, yes, the 2's complement, yes.
Two's complement of B and adding A.
Yes, that is correct, yes. That's going to be A plus B prime. I think it's correct, yes. Yeah. And you have to ignore this last carry, yeah. Okay. So we'll keep A, which is 1, 0, 1, 1, 0, 0, 1. And we would add it to the 2's complement of B, or the radix complement of B. The radix complement of B would be 1, 0, 0, 0, 1, 1, 0. So 1, 0, 0, 0, 1, 1, 0. I'm doing it from right to left. So if you want to read it from left to right, it's going to be 0, 1, 1, 0, 0, 1. 0, 1, 1, 0. If I add these two, 1 plus 1 gives us 0, 1. And this one's come down. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 0, 1. 1 plus 1 is 0, 1. And 1 plus 1 is 0, 1. Because we have a carry on, we would ignore it. The final answer would be 0, 0, 0, 1, 1, 0. Who has this number? Okay, perfect. And why did this happen? Because A is greater than B, and this is a positive answer. If we didn't have a carry on, for example, when you would do it for B minus A, you won't have a carry on. Therefore, you're gonna have a negative answer. And this, the answer would not be your final answer. You have to find the complement. Yes. Maybe, let me double check. Oh, yes. This 0 here. Yeah, thank you. Yeah, I maybe missed this 0. Yes. Yeah, thank you. And you can double check it as well. Can I go to the next question? Yes. Okay, thank you. So we want to find the results of 257 plus 673 in BCD code. So we want to add 257 to 673, but we want to find it in BCD code. Has anyone solved it? Okay, so first we need to convert 257 or 2557 to BCD code. 2 is equal to 0010. Again, as you know, a BCD code has 4 digits and it's between 0 and 9. It starts with 0000 and ends with 1001. Okay, so it's going to 0000 0010 and 5 is equal to 0101 and 7 is equal to 0111. 673 is equal to 0110, 0111 and 0011. Now when we add them, 3 plus 7 gives us what? 10. It gives us 1 0 1 0. Am I correct? But we don't have 10 in a BCD number. What should we do? Add 6 to it. So if I add 6 to it, this is going to be 0 0 0 0, and I have one carry on that I added to the next number. So the next number is going to be 1 plus 1 plus 1 gives us 1 1. Again, 1 plus 0 plus 1 gives us 0 1. 1 plus 1 plus 1 gives us 1 1. And we have here. So what do we have here? We have 1 1 0 1. What is 1 1 0 1? It's equal to 13. Yes, we don't have 13 in the BCD code. So what we do is, again, we add 6 to it. So this is going to be 1 1 0 0, and we have another carry on coming up here. So 0 0 1 1, this is equal to 3. Now 1 plus 0 plus 0 gives us 1. 1 plus 1 gives us 0 1. 1 plus 1 gives us 0 1. So what do we have? We have 9 here. And we have 9 in BCD. So 9 3 0. 9 3 0. And if you add these together, you're going to get 9 3 0. So what is the BCD code? It's 1001, 0011, and 0000. Okay. Now, next question. The inputs of a NOR gate are connected together. What is the resulting gate? So we have a NOR gate, the inputs are tied together. What is the resulting gate? Give you a few minutes again to think on this. Yes. So for a NOR gate, 0 0 is equal to 1. 0 1 is equal to 0. 1 0 is equal to 0, and 1 1 is equal to 1. When they are tied together, it means they can't be different. So these two are out of the picture. The input could be either 0 or it could be 1. When the input is 0, the output would be 1. When the input is 1, the output would be 0. So this is equal to a NOT gate. Is it clear?
That bottom Z would be 0.
Sorry, yeah. Why do I? Yeah, thank you. One plus one, NOR. 1 NOR with 1 is going to give us 0 again. And 0 gives us. Now, next question, if A is equal to 1 and B equal to 0, determine Q. What is Q? Okay, yes. So 1 NaN with a 0 gives us 1. And 1 XOR with 0 gives us what? Gives us 1. Perfect. If they are different, by the way, this is 0. I'm sorry, and my zeros sometimes look like 1. So this is 0. I do my zeros like this. Sometimes it looks like 1, but it's a 0. So 1 XOR with 0 gives us 1. Now I have 1 and 1 in the input of the XNOR. So for an XNOR, if they are the same, what would the result be? 1. So Q is equal to 1. Now, next question. Did you write that down? Can I go to the next question? Okay. What is the minimum number of literals for A with this function, A and with A plus B plus B plus BAA plus AA and with AB plus B? In other words, we want to simplify this function using Boolean algebra. And by the way, I will provide you with the table of the theorems and the postulates. Very close, but no.
So can I use algebra like this? That's AA and that's AB.
Mm-hmm.
I can do that.
Mm-hmm.
And I can multiply those together, right?
Mm-hmm.
And AA just is A, right?
Mm-hmm.
What if it's BBA? That's just AB.
Mm-hmm. There's one step that you didn't do. You skipped over here.
This.
You can use a distributive law. You can use absorption, distribute. There are 3-4 ways to solve it, but all of them have a single result. So the answer should be just one. Again, the first student to solve this gets an extra point, bonus point on their exam. Remind me to give you the extra point. Okay, did you solve it? So let's break it down and make it easier to solve. I'm going to do it one by one. So part A times A plus B, this would be equal to AA plus AB. What is AA equal to? It's A. So this would be A plus AB. Am I correct? Can I write it like this? A times 1 plus B. What is 1 plus B? And what is A times 1?
1.
Yeah, I'm sorry. Yeah. I did it for the second one. A plus AB. We can, yeah. Take out B, it's going to be 1 plus. Yeah, it was correct. What was the problem there? A times 1 plus B.
Plus B.
1 plus B is 1. A times 1 is what? Is always A. It was correct, wasn't it? Yeah. I doubted myself for a second. So the first part, this would be equal to A. Now the second part, B plus AA. What is AA? So this would be B plus A. Am I correct? Yes. Now what about, so this is part 2. That was part 1, part 2, part 3. What is AB plus B equal to? Can I write it like this? Again, B times A plus 1. What is A plus 1? 1. What is B times 1? So this would be equal to what? B. So now what we have A plus B plus A. This is part 1, part 2, plus B. Am I correct? Yes? This is part 3. What is A plus A? What is B plus B? So the answer would be A plus. Again, there are different ways to solve it. This is like one of the easiest ways. So the final answer would be A plus B. Is it clear? Yes? Okay. Now let's solve another one. I think it's better to solve another one as well. So the Boolean expression function f is equal to ab plus a prime b plus a b c. We want to simplify this. Yes, I think it's correct. Yeah. I haven't checked it, but yeah, I think it's correct. Yeah. Do you need more time or do you want to solve it? What is the final answer? Okay, perfect, yes. So we can again break this down. Say this is part 1 and part 2. Part 1, I can write AB plus A prime B like this. B times A plus A prime. What is A plus A prime? It's equal to 1. Therefore, B times 1 is equal to B. Now I can write it like this, B plus A, B, C. Or I can write it like this, B times 1 plus AC. What is 1 plus any variable? It's going to be 1. Therefore, B and with 1 would be equal to 1. The final answer would be equal to B. Okay, that's it for the review class. I would post more information about the review class on Canvas, on the videos. And also I posted an announcement on Canvas. I will send out an email about the date and time and instructions about the final, the first exam on Canvas. Thank you so much, and I will see you next week.
Are we gonna do anything with the canonical